Hello everybody, this is an introduction to complex numbers. We're going to examine here what is a complex number. So imaginary and complex numbers. Well, as you can see on these stamps, this shows Carl Gauss. And remember Gauss, we learned about his numbers before. And Gauss also was one of the people, he was a very brilliant guy, and he was one of the people who came up and worked a lot with what we're going to learn about is imaginary and ultimately complex numbers. So remember, we met him earlier as a child adding 1 to 100. So he also worked on complex and imaginary numbers. So the imaginary unit is defined as I. And this was something why we couldn't do things like take the square root of negative 25 because inside the radical sign because of that negative sign, because really it's I. So it turns out if we do multiply negative 1 times negative 1 as understanding that it's I, it becomes negative 1. So that's a definition that you really have to know. So, as I just mentioned, this is what happens in the case of imaginary numbers. If we start off with negative 25 underneath the radical sign, and we end up separating the real 25, and then multiply it by the negative 1, which we've defined as I, and that's called 5I. So a purely imaginary number can also be combined with a real number to form what is called a complex number. And this is what happens. So for example, if you see something that looks like 3 plus 4i, or 2 minus 5i, or negative 4 minus 3i, this is the real part where the 3 is, and this is called the imaginary part where the 4i is. So a complex number is of the form a, which is the real part, plus bi, which is the imaginary part. So we call the property, if a is positive, then negative a can be, under the radical sign, can be written always as I, where we take out that negative 1, and here's the negative 1, and then the a, and then we can actually figure out what a is if there's a perfect square there. So this is here what I just said. So you take out the negative 1, which is defined as I, and there's the a, and so that makes a positive number. So to justify our rule, we simply square the quantity negative a. So for example, here is what it looks like when we do that. So we have, so I squared, remember we said I squared was equal to negative 1. So we're going to square this whole quantity, and we said I squared is equal to negative 1. And then, so, and here is our other part. Now remember when we said the square root of a squared will be a itself, and then ultimately we get negative a. So this system of numbers consists of real numbers and the set of imaginary numbers. So remember, the imaginary unit is called I, where I is equal to negative 1, and I squared, where I is equal to the square root of negative 1, and I squared is equal to negative 1. And we write each square root in terms of the number I. So, for example, if we're going to look at a few examples, so this is going to be, so I'm going to take out there it is, negative 1 times 25. And then here I have the negative 1, which is that negative over here. And here I have the nice perfect square of negative 25, and we know this is called I, so that's how I get I square root of 25. For 2, again, I do the same idea. Here I have the negative, so I take that out as I, which was the negative 1, like here. And then I 12, and then I simplify it as much as possible. And we learned earlier that 12, there's a hidden perfect square there, which is the square root of 4 times 3, and then we take out the square root of 4 is 2, and then we just write it. Usually we write it this way, where the I is between the number here and the radical here, and this is the standard way of writing it. Similarly for number 3, so here now we just have to work on 32, see is there any hidden perfect squares there, and indeed there is, because 16 times 2 is 32, and then we can pull out the 4, and it becomes 4I square root of 2. Some people may think it's particularly clever to do something like this because, oh, wow, we have a negative times a negative, and that will give us a positive, so therefore it's the square root of 14. Well, if you start doing stuff like that, this destroys the fabric of the universe, because it turns out that this is really a negative 1, the square root of negative 1, and this is a square root of negative 1, and we know that the square roots of negative 1s are i's by definition. So let's look at a few examples using these definitions, where I is equal to the square root of negative 1 and I squared is equal to negative 1. So here is the one we just looked at, example number 4, and we see we have a negative inside the radical sign and a negative inside the radical sign here, so that means we're going to have to take those out as i's, because that would mean this negative is a square root of negative 1 and this negative is a square, so it would be I square root of 2 times I square root of 7. Now, it turns out I and I is I squared, and then we have the square root of 14, because 2 times 7 is 14, and there's no way of really simplifying the 14 any further, but we must simplify the I squared, and we know from here the I squared is equal to negative 14. I mean negative square root of 14. Similarly for number 5, where we have here is exactly our definition of I. And here we have a negative under the radical, which means that this would be negative 1 times 25. So we can now pull out the I from the negative 1 here, and then this negative 1, so we end up with I squared, and there we have the 5I squared, because this is a perfect square, and that means because this, by definition, is negative 1, so that gives us negative 5. Now here we only have one negative under the radical sign, and this one's positive. So we'll take out this I right here, and we end up with I square root of 3, and then times square root of 27. And it turns out that the square root of 3 and the square root of 27 gives us the square root of 81, and there is the I on the outside, which we can't reduce any further, but it turns out that this is a perfect square, so therefore we can write it by convention as 9I. Usually the number comes before I and the I before the radical. Now here is our last one, number 7. And let's look, we see we have a negative under the radical sign, so automatically we think I. And now we have here, we can break this down. We can find that inside here is a perfect square. So here we have 4 times 2, and then we can see that if we take out the 4 The square root of 4 is 2, so we have the 2i, and these two are the same, so we can just cancel out. We don't have to rationalize the denominator because this simply cancels out. Thank you very much for watching, and I hope you enjoyed this video, and stay well and take care.